Alright, this week's HSC questions from 1998 paper, and I'm going to cover two questions. First one's a graphs question, the second one will be a polynomials question. So start with the graphs question. It was question 3. Gave you a function x minus 4 on x and asked to provide half-page sketches of the following functions. The first function was y equals function of x. So what I've done to start with, down here I've already drawn y equals x, the straight line, and I've drawn y equals 4 on x, the hyperbola as well. And so what we're after is y equals x minus 4 on x. So we go to our key points where they intersect. 2 take away 2 is 0, so it's going to be 0 at that point there. And then what we're going to be doing each time is taking away the 4 on x away from the y equals x. So I'm going to take this value away from the value up here, give me a point here. And take this value away from here, and I can see that I'm in the negatives. This value away from that value, and I'm travelling down here. This value away from that value. And you can see that what's going to happen, I'm going to get this curve. The curve's going to get, as this gets smaller, I'm going to be taking away less and less from this one. So my curve's going to go something like this. It's going to come down. It's going to cut through to 0, where the graphs were the same. And it's going to come down. It's going to get really and head down towards negative infinity, down the bottom here, getting very, very small. And so on the other side then, I can see that the graphs are pretty much just a reflection of this. So the same thing's going to happen. It's going to get closer and closer to this curve. It's going to go through negative 2, 0, get closer and closer to that curve, and it's going to come up here. Try and do this. There it is, and it's going to approach that graph. Now that should not be a wonky curve, that should be a nice straight curve. Well, a nice continuous curve rather than straight curve. So this would be y equals x minus 4 on x simply by subtracting the y values away. Okay, next one. It asks me to draw y equals the square root of f of x. So what I'll do over here is I'll just transfer that curve over to here. So I've got this coming down like this. And I've got it going off like that. And similarly here, I've got it coming down something like this. Okay, now I'm asked to draw the square root of this function. Now the square root of this function is only defined where the function is positive. So it's only going to be defined from here up and from here up. Now when the function is less than 1, the square root will be larger than the original function. Where the function is greater than 1, the square root will be less than it. So the square root of 2, for instance, is 1.4. The square root of 4 is actually 2. So I'm going to get a curve that comes up above it. It's going to cross it where it's equal to 1. So when function of x equals 1, then the square root of function of x is also equal to 1. So that's where they're going to intersect, and it's going to head off like this, adopting that square root sort of shape. On the other side, it's a little bit more interesting. Square root of 0 is 0, square root of negative is undefined, square root of 1 is 1, square root of anything less than 1 is bigger than that value, so these values are larger. It's going to come through here. And then what's going to happen here is that the square root of 2, as we said, was 1.4. Square root of 4, this value 4 is 2. And it's going to continue on, and you're going to get this sort of shape happening. And the square root's going to get bigger and bigger and bigger, but they won't actually ever touch the other function. You'll never get the square roots the same as the original function. And so there I get my nice little funky square root of f of x graph. Alright. Now the last one. Last one is e to the function of x. So y equals e to the function of x. So once again, I'll just sketch in the original function, cutting down through 2, heading off towards the axis down here, and coming from the axis, cutting down through negative 2. Something like that. Alright, so now, a couple of key points again. When the function is 0, then e to the power of 0 is 1. So it's definitely going to go through there. Where the function hits 2, e squared is larger. Where the function is 3, e squared is increasing rapidly. So I'm going to get this happening up here. Where the function is negative, then e to the power of a negative is getting smaller and smaller. E to the negative 1, 1 over e. E to the negative 2, 1 over e squared, 1 over e cubed, and so on. And it's going to get down really small. It's going to get close to 0, but not actually hit 0. So it's going to come in like that on this side. This y-axis here stops it from going any further with this break in the original function. So over here is a similar thing. When the function is 0, e to the 0 is 1. When the function has a value of 2, e squared, again, really large. Function 3, e squared, really large. E to the 3, sorry, really large. And again, these negatives, same sort of shape's going to follow on this side. But there's no wall here. This function is going to continue. It's not like it's a y-axis here, so it's going to turn and it's going to head down towards the y-axis and approach 0 like that. So that's the function y equals e to the function of x.